2007 2B, relative. A man can swim 3 meters per second in still water, and he swims across a river of width 30 meters. He sets out at an angle 80% to the bank. The river flows with a constant speed of 5 meters per second parallel to the straight banks. Across the river, he is carried downstream by distance d. Find the value of d corrected to decimal places. Now guys, please remember that what you have here is, if I gave you a more basic example where I was able to swim 3 meters per second in still water and the river itself was going 2 meters per second, okay? The way to label this is velocity of river is 2 meters per second. Velocity of the man in the river is 3 meters per second. However, the velocity of the man to somebody who's looking on the bank is the two of them added together. So you're actually able to go 5 meters per second with the assistance of the river. So please be aware of the language. Velocity river, man in river means how do you swim when there's no current whatsoever. And then finally, what is actually really happening when you're river assisted or the river takes away your speed, okay? So what we're going to do next is we're going to look at this angle here. So we set off at an angle 30 degrees. Okay, so set off this angle here, and this angle here is 30 degrees, and we're going 3. So 3 degrees this way. 3 is the hypotenuse there. So this is going to be 3 sine 30 and 3 cos 30. Otherwise known as 1.5 and 2.6. Are we happy with that? Then what's going to happen is it's what I said earlier. Velocity of man in water equals velocity of man minus velocity of water. Okay, and therefore velocity of man. If I bring the velocity of water over the other side, velocity of man equals velocity of water plus velocity of man in water. Okay. Now, first, what is the velocity of the what's the velocity of the water? It's going to be 5I, isn't it? 5 going to the right, so 5I. And then what is the velocity of the man in the water? We have it here, don't we? This is not taking consideration the velocity of the water, so it's minus 2.6I plus 1.5J. Finally, the velocity of the man is both of them added together. It's going to be 5I plus minus 2.6I plus 1.5J. Gives me a velocity of the man of 2.4I plus 1.5J. Alright, so that's how you can come up with your speed there, okay? Now, what does it want us to find then? He's carried down the bank at distance d. And crossing the river, find d corrected 2 decimal places. Well, this is really easy now, okay? Because you've got your speed, and your speed is going in the direction, your speed here, which is this part here, what direction is that going in? That's going in northeast, isn't it? Well, not exactly northeast, but 2.4, for every 2.4 you go across, you're going to go up 1.5. So that means every second you're going this direction up here. 2.4, 1.5, 2.4, 1.5, 2.4, 1.5. Until eventually you cover 30 meters directly upwards. Does that make sense? So remember what I said? It says 2.4 across and 1.5 up. You're covering 1.5 up every second. You have 30 meters to cover in the upwards direction. So just this time equals distance over speed. So distance over speed, which is going to be what, guys? Your 30 meters divided by 1.5, which is going to get us 20 seconds. Okay, so 20 seconds. Now finally, from these 20 seconds, this means that we're going to travel 2.4 meters to the right 20 times, because we have to multiply distance by time. So distance equals speed multiplied by time, which is going to be, and we're going to do distance in the lateral direction. You're going 2.4 meters to the right, multiply that by 20, and you get 48 meters. That there went for 20 marks. Just somebody's discussing basically a decimal difference. Okay, in the answer, the decimal difference came in here when I rounded off the 2.6 to 1 decimal place. That was technically a small error, so you'd probably leave the 2 decimal places, or you'd leave it as 3, was it? 3 root 3 over 2, and that will put up the accuracy to 48.04. Yes, Adam?
Is that higher or